Hello my dear students, hope you all are doing great. So today's video we are going to discuss the most important 20 previous year questions from the unit kinematics, and here we are covering the questions from the year 2020 to 2022 only. Okay, so the remaining we will be covering in the next video. Great, are you ready? Here comes the first question. Yeah, one more thing. My focus will be how to get to the answer in the easiest way. Alright, so that has to be kept in mind. That will be my approach throughout this video. Question number 1. A helicopter rises from rest on the ground vertically upward with a constant acceleration small letter g. So the constant acceleration is g. A food packet is dropped from the helicopter when it is at height h. The time taken by the packet to reach the ground is close to. So let this be the ground and let this be the height at which the helicopter is. So let this be the helicopter. Okay, fine. Now this is at a height of h from the ground. Now it started from rest and reaching here. So once it is here, definitely it will be having a non-zero value of velocity, that is v in the upward direction, and height is what? H. So the initial velocity of this helicopter was 0 and final velocity is v, and it went up to a height of h, displacement is h, and the acceleration throughout this motion was g meter per second square. So let us try to find out first of all what is this velocity here. Okay, because that is what we must know to calculate the time. So we all know that v square is supposed to be u square plus 2as. Here, since the helicopter started from state of rest, I can mark this equation as v square equal to 2g into h, where a is g and h is the displacement. Now, what is velocity v? Velocity v is under root of 2g into h. Under root of 2g into h. Now, of course, the food packet that is getting detached from this helicopter will definitely be having the same velocity in the upward direction. Now it will go to a particular height, will come to state of rest, and after that it will come back. Okay, now let me first calculate the time taken for this journey of the food packet to the maximum height and back onto the same height. Okay, so the initial velocity is this. So if I calculate this particular journey starting from here, I repeat, starting from here, the displacement of the food packet is going to be 0. It went up and coming back. So here the displacement is going to be what? 0. Alright. So I can say displacement along y-axis is initial velocity along y-axis and time taken plus half of acceleration along y-axis into time taken square. So for this case, displacement is 0. Initial velocity is under root of 2 times g into h. Into time taken, I am taking it as t minus of half of g into t square. Okay, this one and this one will cancel. Okay, and let me take this term towards the left. So here this is going to be what? G by 2. Okay, this came to the left. G by 2 is going to be under root of 2 times g into h. Okay, fine. So I am missing t here. So here small letter t is going to be what? 2 into root of, okay, see, this is going here and this will be coming down. So root of 2 into, this is h upon g. Okay, because this will go in, on denominator I am going to have what? Root of g, and this 2 will be appearing here. So the time taken for the upward journey and coming back onto this particular point, I am getting it as what? I am getting it as 2 times under root of 2h by g. Okay, now please try to understand. It is the time taken by the foot bracket to go up and come back to this particular position. And now it need to travel more. Okay, now have a look. Under root of 2 is 1.414. I repeat, 1.414 into 2. Into 2, here this is 4 2s are 8, 2 1s are 2, again 4 2s are 8. Okay, fine, and 2 1s are 2. So it's coming as 2.828 into root of h by g. Now have a look. Here the coefficient of, I repeat, the coefficient of under root of h by g, it's less than 1. Here it is coming as 1.8. I am having it as 2.8. So this must not be in the list. This must not be in the list. Here it is coming as 2 by 3. That means less than 1. That means this is the only option left. So option C must be the correct answer, because from here to here the time taken is 2.8 into under root of h by g. So a value greater than this should be the correct answer. I hope you got it. Alright. Now let me take you to the next. That is question number 2. Question number 2 says, a ball is dropped from the top of 100-meter high tower on a planet. Okay, the height is 100 meter. In the last 1/2 second before hitting the ground, it covers a distance of 19 meters. The last 1/2 second, it's covering how much? 19 meters. Then the acceleration due to gravity near the surface on the planet is. So we need to find out the acceleration due to gravity. Let us consider this be the ground. Okay, and let this be the mass coming and hitting the ground from a particular height. What is that height? 100 meters. 100 meters. Okay, fine. Now, in this case, we don't know what is the acceleration due to gravity. So I can mark 100, that is equal to half of a into t square. Half of a into t square, I can mark it like this. Now, let us consider the situation where the body is at a height of 19 meter from the surface. Now, what is this distance? This distance is 100 minus of 19. Okay, that is what? 81. So I can say 81 is equal to half of a into time taken is t minus of 1/2. And I can mark it as t minus of 1/2 square, because it is in the last 1/2 second. Last 1/2 second means here this is the time duration is t is equal to 1/2 second from here to here. So here this particular time need to be total time minus 1/2 second. So I marked it like this. Now let me take the ratio. If I take the ratio, here this is going to be 100 upon 81. That is a/2 and a/2 will cancel each other. Here this is going to be what? t upon t minus 1/2 the all square. Now let me take the square root on both the sides. So here this is going to be 10 upon 9. Okay, that is equal to t divided by t minus of 1/2. Now let me cross multiply this. 10 times t minus of 5. This 10 go in. 10 times t minus of 5. That is going to be 9 times t. Okay, rearranging this, I can have here this as what? Just rearrange this. Rearranging, so I can get this as what? Small letter t is equal to 5. Small letter t equal to 5. Now let's have a look. We have this particular expression. So as per this relation, 100 equals, okay, a by 2 into t square. T square means 25. Cancelling this, I am going to get this as what? 4. Now what is the value of A? A is supposed to be 8 meter per second square. Alright, so here the answer need to be 8. I hope you got it right. Now let's move to the next. That is question number 3. When a car is at rest, the driver see raindrop falling on it vertically. Alright, when driving car with a speed of small letter v, he sees that the raindrops are coming at an angle of 60 degree from the horizontal. On further increasing the speed of the car to 1 plus beta times small letter v, this angle changed to 45 degree. Then the value of b is close to. That's a question. So once the car is at state of rest, this is velocity of rain with respect to the man sitting inside the car. Now, once the car start moving in the forward direction, here this is velocity of the rain, here this is going to be velocity of the car. So here this is going to be minus velocity of car. Now here this is going to be velocity of rain with respect to the car. And as per the question, here this angle is what? 60 degree. As per the question, this angle is 60 degree. Now, so here I can mark the magnitude of VC as small letter v as per the question. I repeat, magnitude of VC, I marked it as what? Small letter v. Now I would like to recreate this triangle and I would like to mark this as VR and I would like to mark this as V, and here this is 60 degree. Now the next condition, the V got changed to 1 plus beta times V. 1 plus beta times V. So now it is 1 plus beta times V, and here this is VR, and this angle got what? 45 degree. And we all know that tan of 45 is 1, which means from here I can come to a conclusion that VR is equal to 1 plus beta into V. VR equal to 1 plus beta into V, because tan of 45 is 1 and tan of 45 is what? Perpendicular upon base. That means this need to be equal to this. So I substituted that condition. Okay, now have a look here. From here, tan of 60 is what? Root of 3. That need to be equals to what? VR upon V. VR upon V. Now from here, I can say that VR. What is VR? VR is equal to root 3 times V. So I can put that value here. So under root of 3 times V, that is equal to 1 plus beta into V. V and V can get cancelled. Now what's beta now? From here I can say that beta is equal to root of 3 minus of 1. Root of 3 is 1.732. Minus of 1 is 0.73. Approximately, I can choose option D as my correct answer. Next is question number 4. Here comes question number 4. The question says, a stone is dropped from the top of a building. When it crosses a point 5 meters below the top, okay, another stone start to fall from point 25 meters below the top. Okay, now both the stones reach the bottom of the building simultaneously, then the height of the building is. Please try to understand the question. Let this be the building, okay, and let this be that point which is just 5 meters below, and let this be that point which is 25 meters below, I believe. As per the question, what it is? Yes, 25 meters below. Okay. Now, once the first ball is at a distance of 5 meters from the top, the second ball started leaving. And as per the question, they both reach simultaneously. Okay? Yes. Now, once you drop a ball from here and it came down to a distance of 5 meters, it is supposed to get a speed of v square equals 0 plus 2 into g. I'm going to take it as 10 into h, that is 5. That means here distance traveled is 5, that is v square equal u square plus 2as, 2 into a is 10 and displacement is minus of 5 and acceleration due to gravity I am taking as minus of 5. That is how it is. Minus of 10 into minus of 5 got converted as plus. Okay. Now 5 2s are 10 and 10 into 10 100. So basically v is what? V is 10 meter per second. V is 10 meter per second. Now just have a look. Here is the position. Here this is having 0 speed and here it is having what? 10 meter per second. Both are experiencing same acceleration. What is distance of separation between these two? Here to here it is 5, here to here it is 25. So this distance of separation is how much? Just 20. So the relative separation is 20. That is equal to, what is the relative speed? Relative speed is 10. So the time taken is going to be t. That means they will be simultaneously reaching the ground after t time, and that is equal to what? That is equal to 2 seconds. That's equal to 2 seconds, which means the body is reaching the ground after 2 seconds. That means this particular body is reaching the ground after 2 seconds. Now, if I calculate this particular height, I can say that S is equal to U is 0, half of, okay, acceleration to gravity, I am going to take it as what? Minus of 10, okay, into time taken square means it is 4. So definitely this one and this one will cancel each other. So here this is going to be minus of 20. That means from here 20 meter in the downward direction. That is what the displacement is, minus of 20. And what was this height? That was 25. So here this is 20, here this is 25. So the total displacement need to be what? Minus of 45. In other words, I can say that the height of the building is what? 45 meters. Was that okay? Was that fine? Now let's take you to the next, that is question number 5. Question number 5 says, a swimmer can swim with velocity of 12 km per hour in still water. Water flowing in river has velocity of 6 km per hour. The direction with respect to the direction of flow of river water, he should swim in order to reach the point on the other bank just opposite to the starting point is. That is the question. Again, let's try to understand the situation. So here this is river bank 1. Here this is the another one. Here this is the point from where I want to start the swimming, and here this is the point where I want to reach. So to reach in this direction, definitely, as you know that I need to head in this direction. So here this is velocity of the swimmer, and here this is going to be velocity of the river, and here this is going to be velocity of the swimmer with respect to the ground. As per the question, this is equal to 12 km per hour, and here this is equal to what? 6. You all know that this angle is 60. Now considering that right angle triangle, here this is 90 degree. I think I said this as 60. This is 90 degree. So here this is 12, here this is 6, and this angle is what we are going to find out now from this one. So of course here this is 6, here this is 12. So this angle, if I consider it as theta, sine of theta, that is perpendicular by hypotenuse, that is 6 by 12, that is going to be 1 by 2. So it's clear theta is equal to what? 30 degree. Theta is going to be 30 degree. Now have a look. What they are asking is, this is the direction of velocity of the river, velocity of river. So this angle is 90. We got this as what? 30 degree. So if I consider the velocity of the river and the velocity of the swimmer, this angle is going to be what? 120 degree. What is that 120 degree? 90 plus 30. So here the answer need to be 120 degree. Was that fine? Now let's check the next. That is question number 6. Question says, water droplets are coming from an open tap at a particular rate. The spacing between the droplets observed at the 4th second after it fall to the next droplet is 34.3 meter. 34.3 meter. At what rate the droplet are coming from the tap? That's a question. So the most important part is the spacing between the droplet observed at the 4th second after it fall to the next droplet is 34.3. Okay. So let this be the tap. Let this be the tap. Okay. Let this be the tap. And let this be the first drop. And let this be the second one. And let this be the third one. And let this be the fourth one. And let me take this distance as x. So this is going to be what? 3x. What about this? This is going to be 5 times x. And this is going to be what? 7 times x. Okay. Now you must understand the distance between the fourth one. So this is the first one here. This is the second one here. This is the third one. And here this is the fourth one. As per the question, the distance between the fourth one and the next one, that is marked as 34.3. So 7 times x, that is equal to 34.3. Okay. Now what could be the value of x now? Let's see what could be the value of x. So it's going to be 343 upon 7. Okay. So here this is going to be 4. Here this is 28. And here this could be what? 6, 3. So it's going to be 49. Considering the decimal, it could be 4.9. So x is going to be what? 4.9. X is going to be what? 4.9. So this distance is 4.9. So now here the time taken by the droplet to travel from here to here, that is actually the time between 2 successive drops, because once the first droplet is here, the next one is about to start. So the time taken by the drop to travel from here to here, that is the time gap between 2 successive drops. Am I right or what? Isn't it? Yes. So I am going for the equation s is equal to ut plus half a d square. So s, we know it is 4.9. 0 plus half of a, 9.8. Acceleration due to gravity is supposed to be 9.8. I can mark it as 2 into 4.9. Isn't it? And time taken is coming as what? T square. So here this one and this one will cancel each other. Okay. What was s? S was 4.9. So 4.9 and 4.9 will cancel each other. So here I am getting t square is equal to 1, or t is coming as what? 1 second. That means the time gap between 2 successive drops is 1, which means it is 1 drop per second. I hope you got it right. Next one is question number 7. Here comes the one. The question says a balloon was moving upward with a uniform velocity of 10 meter per second. 10 meter per second. Moving with constant velocity. An object of finite mass is dropped from the balloon when it was at a height of 75 meter. At a height of 75 meter from the ground. The height of the balloon from the ground when the objects strike the ground is around. So here let this be the balloon. Okay. Let this be the basket, and some mass is getting dropped from here. So this particular balloon, it is having a speed of 10 meter per second. Okay, it's having a speed of 10 meter per second. Now, this is already at a height of what? 75 meters. This is already a height of what? 75 meters. So here, any object attached to it, it's also having 10 meter per second. Okay, now it will go up, will come to state of rest, and after that it will reach here. Okay, so time taken for the upward journey is 1. Time taken for the downward journey is also another 1 second. So now the total time taken is what? 2 seconds. Now it will be taking some additional time to travel in the forward direction. I mean the downward direction to reach the bottom. Now already 2 seconds is over. Okay, it's already 2 seconds. So by that time the balloon will be moving in the upward direction. Okay, now once it reaches where the balloon is, that is what we need to find out. So already the time is 2 seconds and our object is here. Now if this body was moving up with a speed of 10 meter per second, here it's coming down with a speed of 10 meter per second. And from here I am going to have a displacement in the downward direction. So I can go for the relation. Displacement along y-axis is equal to initial velocity along y-axis into time taken plus half of acceleration along y-axis into time taken square. So displacement along y-axis is minus of 75 from the origin in the downward direction. Minus of 75 is equal to u is minus of 10 into time taken is t. The downward direction it is, that's why I am taking it as minus, plus half of acceleration due to gravity is again the downward direction, that's why I am taking it as minus of 10 into t square. So this minus will cancel from everywhere. So here this is going to be what? 75, that is equal to 10 times t plus 10 by 2 is 5 into t square. Let me cancel 5 also. Here this will go and here this is going to be 2 and here this is going to be what? Here this is going to be 15. Yes, 15. Okay, so now I got the expression as t square, okay, plus 2t minus of 15 equal to 0. Alright, so here this need to be what? T plus 5 into t minus of 3 is equal to 0. So from here I can say that the value of t is going to be 3 or t is going to be minus of 5. So of course we will be taking this 3. That means it's going to take another 3 more seconds. So the total time taken is 3 plus 2, that is 5 seconds. Isn't it? 2 seconds here and this additional 3 seconds. So time taken is what? 5 seconds. Now in that 5 seconds, this will be moving up in the downward direction of how much? 50 more. So it's already at a height of 75 plus is going up through a height of 50 more. So here this is 5 and here this is going to be what? 12. So the answer need to be 125 meters. Okay. Now let's move to the next, that is question number 8. The question says, a ball is thrown up with a certain velocity so that it reaches a height of h. Find the ratio of the two different time of the ball reaching height of h by 3 in both the directions. So here the ball is, here the building is, which is at a height of h, I can say. Now let me throw a ball which is reaching to the same height. I'm considering it like this, okay. So now let this be h by 3, h by 3. So let this be the height. So here this is the case when it is going up and here this is the case once it is coming down. So definitely this height is what? 2h by 3 while coming down. This height is 2h by 3 and here this is what? H by 3. Okay. Now, let me first calculate what is the time taken by this body to travel from the top to the bottom. So for that, I can go for the equation h is equal to t plus half it square. So the distance traveled in the downward direction, it is 2h by 3. So displacement I am going to take it as minus of 2h by 3. So minus of 2h by 3, that's going to be half of again minus of g. So that minus and minus will cancel each other. So okay, let me substitute that. Minus of 2h by 3, that's equal to minus of half of g into t square. Minus and minus will cancel each other. Now please tell me, what is the value of time t? The value of time t is going to be here 2 into under root of h by 3, because 2 to the 4, root of that is 2, isn't it? Is that fine? So the time taken is 2 into root of h by 3. Now let me consider the case, what is the time taken by the body to travel from top to the bottom, the entire journey. There the time is supposed to be under root of 2h by, I think I missed something here. This g term need to be here, no? Yeah. Under root of 2h by g. That's going to be the time taken by the body to travel from top to the bottom. The same is going to be the time taken by the body to travel in the upward direction. Okay. Now please try to understand the case. The time taken by the ball to reach the top, it is under root of 2h by g. Okay, it's under root of 2h by g. The time taken by the body to travel from here to here, that is root of h by 3g into 2. So if I mark this as t1 and t2, I repeat t1 and t2, t1 is going to be this time, that is under root of 2h by g minus of this time. Which one? This one. That's going to be what? 2 into root of h by 3g. Okay, all divided by, okay, so that is t1. And what about t2? t2 is supposed to be under root of 2h by g, okay, 2h by g plus 2 into under root of h divided by 3g. Okay, this is going to be t1 as well as t2 respectively. Now, of course, we need the ratio of these two. So, it's going to be t1 divided by t2. If I am taking t1 by t2, here in all the case, root of h by g is common. So, that is going to get cancelled each other. Okay. Now, what I have here is under root of 2 minus of, here what I have is 1 by root 3, all divided by, here it is going to be root 2 plus 2 by root 3, it's going to be. Is that fine? Here this root 2 is there, here it is 2 divided by root of 3. If I go ahead with the calculation, okay, what I can have here is, just have a look. Here this is going to be under root of 3 into under root of 2 minus of, I can mark this as root of 2 into root of 2, all divided by, here this is going to be root of 2 into root of 3 plus under root of 2 into under root of 2. Alright. Now again root 2 is common. That will get cancelled each other. Now what I have is root of 3 minus root of 2 all divided by root of 3 plus root of 2. This is t1 divided by t2. Fine, which means option 3 should be correct answer. Root 3 minus root 2 upon root 3 plus root 2. Got it correct? Okay. I'm just briefing what happened here. I calculated what is the time taken by the body to travel from here, top to this distance, that first. And then I calculated what is the time taken by the body to travel from the entire journey. So same is going to be the time taken for the upward journey. So the time taken for the upward journey plus the time taken for this, that's going to be T1, minus time taken for the this particular journey, that is going to be T2. So I just took that T1 plus T1 as well as T2, then I took the ratio. I hope you got it right. Next is question number 9. The question says the ranges and the heights for two projectile projected with same initial velocity. You must not miss this. Same initial velocity at an angle of 42 degree and 48 degree with the horizontal R1 and R2 and H1 and H2 respectively. Choose the correct option. Here you must understand the angle of projection theta is equal to what? 42 degree and theta 2 is equal to what? 48 degree. This 42 degree, it can be marked as 45 minus of 3 degree, and here I can mark this as 45 plus 3 degree. And what is the key concept? If I am having a projection at an angle of 45 plus theta or 45 minus theta, I repeat, 45 plus theta or 45 minus theta. In both these cases, the range has to be what? The same. That's a key concept behind this. So here it satisfies the situation, 45 minus theta, 45 plus theta. So R1 need to be equal to R2. That is for sure. Okay, so these two are not in the list. Now speed is the same. So for the first one, that means 45 plus theta, the range need to be what? Maximum. Okay, I repeat, for 45 plus theta, range need to be, height need to be maximum. So 45 plus theta means it is 48. So 48, the height need to be what? Maximum. That means H2 need to be greater than H1. So this is not in the list. So option 2 must be correct answer here. Okay. Now let's move to question number 10. The question says, from the top of a tower, a ball is thrown vertically upward which reaches the ground in 6 seconds. A second ball thrown vertically downward from the same position with same speed reaches the ground in 1.5 seconds. Now, a third ball is released from the rest from the same location which reaches the ground in that second. That is the question. So let this be the tower. Let this be the ground. I am throwing a ball in the upward direction. It will reach the maximum height and it will come back and hit the ground. And this is happening in t is equal to 6 seconds. Now, if this is throwing with the speed of u meter per second the upward direction, here this is again throwing with the same speed and it is reaching here in 1.5 seconds. So if this is going up with the speed of u, while reaching here, this is also going to have the same speed. Now from here to here it is taking 1.5 seconds. That means for the upward journey plus downward journey until here, it is just taking what? 4.5 seconds. And plus another 1.5 will give the total time duration as 6 seconds. Now the time taken for the upward journey, that has to be what? The total time is 4.5 by 2. That need to be what? 2.25 seconds. So the time taken by this body to reach the maximum height is 2.25 seconds. Now let us find what is this u. We all know that once it reaches here, the final velocity is 0. Initial velocity I am marking it as u. Now v equal to u minus of g, I am taking it as 10 and time taken is what? 2.25. So here the value of u is equal to what? Value of u is equal to 22.5 meter per second. So once throwing down, it's traveling the speed of again 22.5 meter per second only. Now displacement, that is equal to what? Ut plus half of a into t square. Displacement is in the downward direction. So s is equal to, what is u value? minus of 22.5 into time taken is 1.5 plus half of acceleration is again minus of 10 into the downward direction time taken is going to be 1.5. So square is 1.5 square. Okay. Now here I have got minus common, so that will be coming out. So minus of, here it is now 22.5 into 1.5 plus, I got here it as what? 5 into 1.5 into 1.5. Now, if I multiply with 100 on the top and the bottom, I can have it as minus of 1 by 100. That is equal to, here I what have? Here what I have is, so I told you I multiplied 100 on the top as well as bottom. So here I am going to get it as 225, okay, into 15 plus, here it is going to be 15 into 15 into 5. It's going to be like this. Now, if I go ahead with this particular calculation, here this is what? 15 square. So, displacement S, that is going to be minus of 1 by 100 into 15 square into 15. That's what I have here. 15 square into 15 plus 15 square into 5. So now 15 square is common, definitely that will come out. Now 15 square into what I have is 15 plus 5, that is 20 inside, minus these there upon 100. Okay, so of course this one and this one will cancel each other. Now displacement along downward direction, S I am getting it as minus of 225 into 2 by 10. So here this is going to be what? Here this is supposed to be minus of 450 by 10, or I can say displacement S is equal to minus of 45. That means this particular distance is what? 45 meters. Now the question is, what is the time taken by the body to reach that particular distance? The one which is getting dropped. For the one which is getting dropped, S is equal to what? Ut plus half a t square. This value is going to be 0. Now we got the value of S as what? Minus of 45. Okay. That is equal to minus of 1 by 2 into acceleration due to gravity. I am taking it as 10 into t square. So of course minus and minus will cancel. Here this is going to be what? 90. That is equal to 10 times t square. Now what is t? T is coming as root of 9, that is 3 seconds. So the time taken for the ball which is dropped from the same height, it is 3 seconds. Now let's move to question number 11. The question says, an object of mass 5 kg is thrown vertically upward from the ground. The air resistance produces a constant retardation force of 10 Newton throughout the motion. The ratio of time of ascent to time of descent will be equal to. That is the question. Okay. So I am throwing a ball in the upward direction. The mass of this body is 5 kg. And there is a retardation force. Retarding force is always going to oppose the direction of motion. So that retarding force is how much? 10 Newton. So this retarding acceleration, or you can say the retardation, that is going to be what? 10 by 5, that is 2. So once the body is moving in the upward direction, I can mark the acceleration A1 as acceleration due to gravity. I am going to take it as 10. Okay, because it's told to us that we can take it as 10. In addition to that, we are having 2 more. So that's going to be what? 10 plus 2, that is 12. Okay. So the body will reach to a particular height, say h. And throughout that motion, it is going to experience an acceleration of what? 12 in the downward direction. Now, let me take the time as t1 for the upward journey. And let me assume the body is thrown with a speed of u meter per second. In this case, I can say that since the final velocity is going to be 0, for the equation v is equal to u plus at, in this equation if I consider the upward motion, here this is going to be 0, that is u minus of 12 into time taken is t1. So here I can say t1 is going to be what? U by 12. Okay. Now this body is thrown with the speed of u and it's reaching to a height of what? Capital H. Let me find out what is the value of h here. We know that v square equal to u square plus 2a into s. Here the final speed is 0. Initial velocity I am taking it as u. So it's u square minus of 2 into what is acceleration? Acceleration is minus of 12. So that's why this minus is here, and 12 into height I am taking it as what? H. So here I will be getting the value of h as capital H, that is equal to u squared divided by 24. 12 into 2 is 24. So that is height h. Now this body, to start its journey from height h and need to reach the ground. So for that downward journey, I can go for the expression as s is equal to again ut plus half of at square. This time the displacement is h. Okay, in the downward direction. So I am going to mark it as minus of h. That is equal to, since the body is getting dropped from the height, so I can take u as 0. Now half of, again acceleration is in the downward direction. So downward direction we have got g and retardation is there in the upward direction. So g is 10, retardation is 2 in the upward direction. So it's going to be minus of 8. Minus of 8 into t2 square. So this minus and minus will cancel each other. Now what is the value of h here? Value of h is u square by 12. Sorry, u square by 24. Now u square by 24, that is equal to, here we have got what? 4 times t2 square. Now you have got two equations. Equation number 1 says t1 equal to u by 12. I repeat, t1 is equal to u by 12, or I can say t1 square, that's equal to u square by 12 into 12. Now I have got another equation, that is t2 square equals t2 square, that is equal to u square divided by 24 into u square divided by 24 into 4. Now let me take the ratio. t1 square divided by t2 square, that is equal to, have a look, u square divided by 12 into 12 into, here it is, u square into 24 into 4. U square and u square will cancel. 24 and 12 will cancel, it will leave 2 here. Again this one and this one, sorry, let me cancel this and this, it will leave 3 here. So t1 square divided by t2 square is now equal to what? 2 by 3. Or t1 upon t2 is going to be root of 2 by root of 3. So if I check the option B must be correct answer in this case. Was that fine? Now let's move to question number 12. The question says, a ball is projected vertically upward with an initial velocity of 50 meter per second at t equal to 0. Okay. Now at t equal to 2 seconds, another ball is projected vertically upward with same velocity. Okay. Now at t equal to dash second, the second ball will meet the first ball. That is the question. So here this is the ground and I am throwing the first ball with a speed of 50 meter per second. Okay. Now after 2 seconds, let me say the first ball is here and the second one is about to launch with a speed of 50 meter per second. So after 2 seconds, since the acceleration due to gravity can be taken as 10, the first ball, it will be having a velocity of what? 30 meter per second only. And in the first 2 seconds, this body will be traveling through a particular height. Okay, now let's see what's going to be that height. So that is going to be ut plus half of a t square. What was u? U was 50 in the upward direction. So I am going to take it as plus 50. Into time taken is what? 2. Minus of half of 10 into 2 into 2. So this one and this one will cancel each other. Here this is what? 20 and here this is 100. So which means it is at a height of what? 80 meter. That means with respect to these two, the distance is what? 80 meters. So the relative separation is 80 meter. And what is their relative speed? Here this is 30 and here this is 50. So the relative speed is 50 minus 30. Of course, 20 meter per second. Relative velocity is 20 meter per second. Relative separation is 80 meter per second. So 80 meter per second, that is 80 meters, that is relative separation, that's equal to 20 meter per second into time taken. So of course this one and this one will cancel each other. So here this is going to be what? 4 seconds. That means in the next 4 seconds, it will be meeting. So this process started, like means this relative motion started already after 2 seconds. Now again after 4 seconds the body is going to meet. So the total time taken is what? 4 plus 2, that is 6 seconds. So that is the answer for this question. Now let's move to the next, that is question number 13. The question says, a girl standing on road holds her umbrella at 45 degree with the vertical to keep the rain away. Okay, now if she start running without umbrella with a speed of 15 times root 2 km per hour, the raindrops hit her head vertically. The speed of the raindrop with respect to the moving girl is. Let us understand the situation first. So here, initially, this was velocity of rain and this is marked as what? 45 degree. Now, if the girl started running in this direction, like here this is velocity of the girl, then I can mark this as minus of Vg and this is going to be what? Velocity of rain with respect to the girl. And this is what the situation is. Now, since this angle is 45 degree, I can say that these two need to be what? The same. So, velocity of rain with respect to the girl, magnitude of that need to be what? Velocity of the girl with respect to the ground. I am telling about the magnitude. Now, what is the velocity of girl? Velocity of girl is marked as 15 into root of 2. So, velocity of rain with respect to the girl is again 15 into root of 2 only. Now, we need to get it matched with the options. Okay. So, what I am going to do is, let me multiply with this number with 2 and divide this with 2. So, here I can mark 2 as what? Under root of 2 into under root of 2. This under root 2 and under root 2 will cancel each other. This is what we got converted like this. And 15 into 2 is what? 30. So, the answer is 30 divided by root 2. That means option C is going to be the correct answer in this case. Next is question number 14. The question says, two balls A and B are placed at the top of 180 meter tall tower. Okay, so the tower is 180 meter tall. It is 180 meter tall. Ball A is released from the top at t equal to 0. This is ball A. I am releasing it at t equal to 0. and ball B is thrown vertically down with an initial velocity of u at t equal to 2 seconds. So at t equal to 2 seconds, here this is the first ball, and here I am throwing this with a speed of u meter per second. Now, after a certain time, both the balls meet at 100 meter above the ground. This is 100 meters, and here both the ball meet. Okay, so here this is 100, that means this distance is what? It need to be 80 meters. Alright, after certain time. Now the question is, find the value of u. Find the value of u. That is what we need to find out. So since the first ball was dropped, in the first 2 seconds, I repeat, in the first 2 seconds, it is going to travel a distance of s is equal to 0 plus half of g into t square, that is 4. So of course, it is going to travel a distance of what? 20 meters. So the relative separation between these two balls is 20 meters. What it is? 20 meters. And that 20 meter distance is going to be covered by this particular ball. Okay, once it reaches here. Now that height is what? 80 meter. Now what will be the time taken by the first ball to cover that 80 meters? That is 80 is equal to, the first ball was dropped, so u is 0. So ut is 0 plus half of acceleration due to gravity, I am taking it as 10. Here it is minus of 80 and minus of 10, that's why I am ignoring the sign. Okay, so half of a into the time taken is t square. So this one and this one will cancel each other. So then now time taken is what? T is equal to 4 seconds. Okay, that means the time taken by the first ball to reach till 80 meter is what? 4 seconds. And the second ball started its journey after 2 seconds. Now what all happens is, like this 80 meter, sorry, this 20 meter relative separation, I repeat, this 20 meter relative separation is being covered in a time gap of just 2 seconds. Okay, now let's consider that. This is the first one and here this is the second one. It has got a value of what? U now. Okay, and of course this is again having a speed of what? 20 in the downward direction, because after 2 seconds this body is going to get a velocity of what? 20. So here this is having a velocity of what? 20 meter per second the downward direction. Now of course if they are meeting each other after next 2 seconds, okay, that means of course u need to be greater than 20. So the relative velocity is going to be u minus of 20. That is equal to, okay, the relative velocity is u minus of 20 into, what is the time gap? The time gap is 2 seconds. The time gap is 2 seconds. I repeat, the relative velocity is u minus 20 and the time taken to cover this relative separation, that means relative separation was 20, in the next 2 seconds it is getting covered, so the time taken is 2 and they are covering a distance of how much? They are covering a distance of relative separation of 20. Relative separation is that initial time that is getting covered. Okay, now of course u minus of 20, that's equal to 10 and u is going to be what? 10 plus 20, that is 30 meter per second. Which means option D is going to be the correct answer in this case. So next comes question number 15. Question number 15 says, a bullet is shot vertically downward with an initial velocity of 100 meter per second from a certain height. Within 10 seconds, the bullet reaches the ground and they instantaneously come to rest due to perfectly inelastic collision. The velocity time curve for total time of 20 seconds is. So the initial velocity is minus of 100. So since it is minus of 100 initial velocity, so I can consider this. Here initial velocity is 0. I cannot consider this. Here initial velocity is plus 100. I cannot consider this. Here the initial velocity is minus 100. I can consider this. Now it's projected in the downward direction. So I cancel these two options. Now here if I consider the next 1 second, the velocity is increasing and becoming 0. So this is not in the list. So the final option need to be option A. Alright. Next is question number 16. The question says, a body of mass 10 kg is projected at an angle of 45 degree with the horizontal. The trajectory of the body is observed to pass through 20, 10. If capital T is the time of light, then the momentum vector at t equal to capital T by root 2 is. That is a question. So here the mass is 10 kg, okay, and angle of projection theta, that is equal to what? That is given as 45 degree. Now they are asking the momentum vector at a particular time, and what is that time? T is equal to capital T by root 2. Now of course, to get this particular momentum at the time capital T by root 2, of course we must know the value of velocity of projectile, I mean initial velocity of the projectile, and we must know what is the time value. Without that, we cannot get into an answer in this given format. Okay, so here the key concept is we must know what is the value of Vx and what is the value of Vy when time t equals to capital T by root 2 first, and after that m into Vx I cap plus Vy j cap. This is going to be my final answer. So this is the key concept of this question. Now the point is how to get Vx and how to get Vy. So regarding Vx, as you know that Vx is supposed to be u cos theta. Now we know about the value of theta, but we don't know value of u. And Vy, that is going to be uy minus of g into small letter t. Okay, again with, and what is uy? Uy is supposed to be u sine of theta. Now again, what's missing here? U is missing here. So the most important part over here is how to get the value of u. For that, the coordinate 20, 10, that means this is a point through which the projectile is passing. What does it mean actually? It means when x coordinate of the projectile is 20, y coordinate is 10. That is the information. So let us rely on that information to get the value of u. You all know that displacement along y axis, that is supposed to be initial velocity along y axis into time taken plus half of acceleration along y axis into time taken square. S is equal to ut plus half ut square. Basically this is that equation only. Now you all know that for a projectile, x is supposed to be ux into time taken. That means the displacement along x axis is velocity along horizontal direction, I mean velocity along x axis into time taken. And what is this? This can also be written as x equal to ux is what? U cos theta into time taken. From here I can say that t is equal to x upon u cos of theta. Now if I substitute this value over there, y is supposed to be, I told you what is uy? Uy is u sin theta. It is u sin of theta into, instead of small letter t I can have what? X upon u cos theta. Okay, minus of here this is g by 2 into t square is x square upon u square cos square theta. You know that u and u will cancel each other. Sin theta by cos theta is going to be tan theta. So y equals x times tan of theta minus of g into x square upon 2 times u square cos square theta. This is what we call it as trajectory of a projectile. I repeat, trajectory of a projectile. And here we know the value of x, we know the value of y. What is value? what it was? It was 20 comma 10. 20 comma 10. That means when x is equal to 20, y is equal to 10. Now let me substitute that here. So of course y is 10. So here 10 is equal to x is what? 20. Tan of 45 is 1. Okay. Minus of g, I can take it as what? 10 into x square means 20 square. That is 20 into 20. All divided by, I have got 2 here, u square into cos theta is 1 by root 2. Square of that is 1 by 2. This one and this one will cancel each other. Now let me take this towards the left. So once I take this towards the left, 10 into 20 upon u square, that is supposed to be equal to what? 20 minus 10 is 10. This one and this one will cancel each other. From here I can say that u equals to what? 20. So I told you everywhere to begin with and finally get into this, what was the value that we are immediately looking forward to? We were looking forward to the value of u. Now you got the value of u here. Now another thing what we need is time. They say that the time is equal to what? Capital T by root 2. Now the point is, what is capital T? You all know that capital T is 2u sin theta by g. 2u sin theta by g. Okay. Now what is u here? It's supposed to be u sin theta. So it is 2u sin theta divided by g. Okay. I mean to say that vertical component, that is 2u sin theta by g. Generally we say that 2u by g, like for the upward motion and downward motion, and here if you consider the upward motion, the vertical velocity component is what? U sin theta. So it is 2u sin theta by g. Now capital T equals, okay, 2 into, what is u value we got? We got it as what? 20. Into sin theta means 1 by root 2 into g can be taken as 10. Here this one and this one will cancel each other. So capital T is coming as 2 root 2. And what was small letter t? Small letter t was capital T divided by root of 2, which means it's going to be 2. Okay. Now we got the value for small letter t, that is 2 second, and we got the value for small letter u also. What it is? 20. Yes. Now if I consider the general expression, I told you to get the linear momentum m, it need to be what? M into Vx I cap plus Vy j cap. Now let me go for Vx. Vx is supposed to be u cos theta. That is, u is what? 20, and here this was what? 1 by root 2. So I am going to get this as what? 10 root 2. Alright, because this is going to be 2 into 10. 2 by root 2 can be written as root 2. So it's basically 10 root 2. So 10 root 2 I cap, that is Vxi. Now Vy j cap, that is supposed to be, initial velocity is what? Initial velocity is again 20 into 1 by root 2, that is u sin theta. Okay. Minus of acceleration due to gravity is 10 and time taken is what? 2 seconds. So here this can be written as again 10 root 2 minus of 20. Okay. Now finally linear momentum is equal to mass of the body is 10. Mass of the body is 10 and velocity along x-axis, that is 10 root 2 I cap, alright, plus velocity along y-axis is 10 root 2 minus of 20 into j cap. Once I take 10 in, here this is going to be 100 times root 2 into I cap, plus if I take 10 in and if I can take this out, so here this is going to be what? 10 into 10, here also it's going to be like I can take 10 as common, so 10 into 10 here it's going to be 100, okay, into under root 2 minus of 2, okay, into j cap. I took only 10 out. So this is my final answer, and if I check with the options here, it seems I need to take this 100 in. Yes. So here this is going to be 100 under root 2 I cap plus here this is going to be 100 into root 2 minus of 200 j cap. Okay, which means option D must be the correct answer here. Okay, 100 times root 2 I cap, that is there, and we need to cross check this, that is 100 root 2, 100 root 2, isn't it, minus of 200 j cap. So that was how we proceed. So there were so many concepts was included in this question, the detailed solution. Okay, there I told you about how to get into the answer first. Okay, there I told you how to get the expression for linear momentum at any particular instant, that is basically m into final velocity. Final velocity here it is represented in form of the rectangular components, and to get Vx value and Vy value, I relied on this equation, that is equation of trajectory. You can see even in fact I derived how to get this equation of trajectory. The benefit of this equation is if you know the value of x, you can get the value of y. The only thing is that you must be clear with the value of u as well as theta, that's all. There how you got the value of u, and later on we, with the help of u as well as theta, we got the value of time, and then finally for that given time we calculated ux and vx, and there we got the final answer. Now let's move to the next, that is question number 17. Question number 17 says, two inclined planes are placed as shown in the figure. A block is projected from point capital A of inclined plane AB along its surface with velocity just sufficient to carry it to the top. Velocity was just sufficient to carry it to the top. This is very important. Okay. Now point B is at a height of 10 meter. That's also given. Point B is at a height of 10 meter. After reaching the point capital B, the block slide down on an inclined plane BC. The time taken it to reach to the point capital C from A is small letter t into root 2 plus 1 second. Then the value of small letter t is. Now you must understand the time taken to reach the point C from A. That means basically they are asking for this total time. And that total time is given as small letter t into root 2 plus 1 second. Then the value of small letter t is. That's what they are asking in the question. So, of course, to know about the time, we must know with what speed this body was thrown in the upward direction. To get into that, they have given an information, that is the speed was given in such a way that this body managed to reach here. Alright, and this point is at a height of what? 10 meters. Okay, which means the initial kinetic energy of the body, half of mv square, can be written as m into g into h. M and m will cancel each other. So v square, that is equal to 2 into g is taken as 10 and h is what? H is given as 10. So basically v is equal to 10 root of 2. V is equal to 10 root 2. That is what is given. Now once the body is climbing in the upward direction and reaching onto the top, that at the topmost position, the final velocity of the body is 0. Now I am going to consider the journey from A to B. The final velocity is equal to 0. Initial velocity, that is equal to what? 10 root 2. That means velocity at A, that is 10 root 2. Alright. And what is going to be the acceleration in the downward direction? That is g by root 2, because here theta is 45 degree. It's supposed to be g sine theta. Sine theta is going to be sine of 45 degree, that is 1 by root 2. So that's why I took it as what? G by root 2. Now if I consider that expression, final velocity is equal to initial velocity, that is 10 by root 2 minus of 10 by root 2. It's 10 root 2 minus of 10 by root 2 into time taken for the upward journey. I am going to take it as what? I am going to take it as t1 only. Okay. Now here, if I rearrange this, I can say that t1 into 10 by root 2. That is equal to 10 into root 2. So of course, this one and this one will cancel each other. So I am going to get the value for T1 as 2 seconds. That means A to B, the time taken is what? 2 seconds. Now, let me consider the journey in the downward direction. As per law of conservation of energy, once it reach here, the final velocity again need to be what? 10 root 2. But here acceleration is g sine 30, the downward direction, and sine 30 is 1 by 2. So here the acceleration is g by 2. So considering that, final velocity need to be what? 10 root 2. That is equal to initial velocity I am taking as 0, and here this is g by 2 into time taken I am taking as what? T2. So here 10 root 2, that's equal to g is 10 only, 10 by 2 into T2, 10 and 10 will cancel. So T2 is going to be what? T2 is going to be 2 root 2. Now what was T1? T1 was 2 seconds, and T2 we got it as what? 2 root 2. Now the total time taken, capital T, that is going to be what? 2 plus 2 root 2. And here I can take 2 as common. Here this is 1 plus root 2. And as per the question, this expression is given as what? This expression is given as small letter t into root of 2 plus 1. Small letter t into root of 2 plus 1. So of course this one and this one will cancel each other, which means small letter t is equal to what? Number 2. Okay. So here small letter t is equal to what? 2. That is a final answer. Okay. Next is question number 18. The question says a ball is thrown vertically upward with a velocity of 19.6 meter per second from the top of a tower. The ball strikes the ground after 6 seconds. Now the height of the ground up to which the ball can rise is k by 5 meter. Then the value of k is. So let this be the ground, and I am throwing this ball with a speed of 19.6 meter per second. And it's clearly mentioned this time we need to take small letter g as 9.8 meter per second square. And you know that if initial speed is 19.6, that means this particular body is going to move in the upward direction for a time duration of 2 seconds. After that it will come to state of rest, and while coming down it's going to take the same time, and the next 2 seconds it will reach the ground. Why I am saying 2? Because the total time taken is 4. So the key concept over here is the time taken for the upward journey and time taken for the downward journey need to be the same. And if the speed is 19.6, that means in next to 2 seconds the body will come to state of rest. So for the upward journey it is 2 seconds. For the downward journey it is 2 seconds. Now the body is at the place from where it was thrown. Now total time is given as 6. So it's going to again travel downward direction for 2 more seconds. That is the thing. Okay. Now let us consider the upward journey first. The speed is 19.6 here and is moving in the upward direction, and at the topmost point the final speed is going to be what? 0. So I am going to use the equation v square equals u square plus 2 times a into s. Final speed is 0. U square means 19.6 into 19.6 minus of 2 into 9.8 into s or h I can mark. This height I am marking it as h. Okay. So of course rearranging towards the left, 2 into 9.8 that is 19.6 into h, that is equal to 19.6 into 19.6. This one and this one will cancel each other. So h is equal to what? 19.6. That means from here to here it is 19.6. Okay. Now if this was thrown in the upward direction with a speed of 19.6, so while moving in the downward direction also this is going to have the speed as what? 19.6 meter per second only. Now in next to 2 seconds it's going to travel in the downward direction, and let me see what is this height now. That is small letter h I am marking. So small letter h, that is going to be, so here I am going to use the equation as what? S is equal to ut plus half a t square. So ut plus half of a into t square. What is u here? U is equal to minus of 19.6 into time taken is 2. Okay. Now minus of half of 9.8 into 2 into 2. So of course this one and this one will cancel each other. 9.8 into 2 is 19.6. Here I have got minus of 2 into 19.6, minus of 19.6. So basically I am going to get it as minus of 3 into, okay, here this is 2 times 19.6 and here I have got 19.6. So here this is minus of 3 into 19.6. This negative sign says that the body is traveling in the downward direction from the origin. So now already I have got a height of 19.6 onto the top, and towards the bottom I have got what? 3 times 19.6. Now the question was up to what height the body can rise with respect to the ground. Okay, so total it is what? 3 times 19.6 is the maximum height. So the maximum height from the ground, h max, I got the magnitude as 4 into 19.6. How? 3 times 19.6, that is this distance, and 19.6 was in the upward direction. So altogether it is 4 times 19.6, and we can equate that is equal to what? K into 5, and that's equal to what? K into 5. So we need the value of K basically. Now K is supposed to be what? 5 4s are 20 into 19.6. I can write this as what? 2 into 196. Okay, so 196 into 2, that is supposed to be 6 2s are 12, 1, 9 2s are 18, plus 1 is 19, left with 1, 2 1s are 2 plus 1 3. Answer is 392. So the value of K is equal to what? 392. Was that fine? Now let's move to the next. The question says a ball is released from a height of small letter h. If t1 and t2 be the time required to complete the first half and second half of the distance respectively, then choose the correct relation between t1 and t2. So the ball is released from a height. So means basically it's starting from state of rest. So let me take this be the total height, and I am marking this as the half of the journey. So the time taken to travel from here to here, it is marked as t1, and the time taken to travel from here to here, it is marked as what? T2, and we need the relation between these two. That is what they are looking forward to, isn't it? Of course. So let me take this as h by 2, and let me write the expression for this first, for the first half journey. So the first half journey, let me take the equation as again s is equal to ut plus half a t square. S is equal to ut plus half of a into t square. Now you know that here the initial velocity is what? 0. So I can say that h by 2 is equal to g by 2 into t1 square. Okay, so of course this and this is going to cancel each other. Now I am going to get the value for t1 as, what's t1? T1 is root of h by g, capital H by g. Now let me take the time taken to travel from here to here. There, that particular time, let me take it as capital T. Capital T is supposed to be under root of 2h by g. That we all know, it's direct substitution. Total height is h, half of gt square. So here it is going to be h, 2 will come over here and g will come down. So that is root of 2h by g. Now from here, what is small letter t2? Small letter t2 is supposed to be capital T. Capital T is root of 2h by g minus t1. What was t1? t1 was root of h by g. Okay, now have a look. I can mark this as t2 equals, this is basically what? Root of 2 into root of h by g minus root of h by g, and root of h by g is t1. So I can have the final expression as t2 is equal to t1 will come out because this is t1. Root of h by g is t1. So t1 can be out, and here it is going to be what? Root 2 minus of 1. So t2 is equal to root 2 minus of 1 times t1. That means option D is going to be correct answer. So that was all from my end for this segment. Stay tuned for the next video. Till then, take care and bye bye.